In this discussion video, we will do some infinity minus infinity limit examples. So I want to look at question number 7, parts H and I from worksheet 2, and I've copied those problems here. And I want to look at part H first, and let's start this question together, and then as we make a little bit of progress with it, I'll give you a chance to try it on your own. So remember, the first step is we plug in. And if I plug 4 into this, we will get 1 over 0 for the first fraction, minus 8 over 0 for the second fraction. So we have two fractions of the form non-zero on the top and 0 on the bottom. And our strategy there is usually to evaluate the one-sided limits. And the one-sided limits will either be infinity or negative infinity. So each one of these fractional things is some type of infinite expression, depending on which side you're approaching it from. So you have some type of infinity minus some type of infinity, and this is indeterminate. This is indeterminate, meaning I don't know what it is just by looking at it, because we are not sure which term is growing faster. So both of these fractions are getting really, really big, but maybe one of them is getting bigger a lot faster than the other one. The way I like to visualize an infinity minus infinity is imagine a game of tug of war. So I've kind of drawn like a skinny rope here, and imagine that you have some people pulling on this rope. Alrighty, so I've drawn in some people, and imagine that each one of these kind of represents an infinity. So this person represents an infinity, and this person represents an infinity. Each one of those infinities is kind of sort of tugging on the rope and saying like, I'm bigger, no, I'm bigger. Depending on which one's bigger, that's going to dictate what this overall subtraction ends up being. In the same way that whoever's a little bit better at tug of war will end up dictating who wins this game. All right, so what do we do when we have an indeterminate form? Well, we simplify. So let's simplify this expression first. Okay, so one thing that's going to help us in simplifying this is the denominator, x squared minus 16 factors as x minus 4 times x plus 4. It's the difference of squares. And now we can get a common denominator. We have the limit as x approaches 4 of, and then with this first fraction, I'm going to multiply the top and the bottom. Let me just write it as it is first. But then I'm going to multiply the top and the bottom by x plus 4 over x plus 4. With the second fraction, I don't need to multiply the top and the bottom by anything. It already has the same denominator. 8 over x minus 4 times x plus 4. Now I can combine these into 1. The limit as x approaches 4. So I get x plus 4 on the top minus 8, which is x minus 4. So that's nice. The bottom is x minus 4 times x plus 4. And now I get my nice cancellation. And after I cancel, now let's try to plug 4 in. So on the numerator, I'm left with 1. And on the bottom, I get 8. And that's my answer. So here I have a situation where infinity minus infinity ended up being 1/8. Let's look at another part I. Notice it's a super, super similar function. All I've just changed is the 8 to a 7. Okay, so for this one, I want to first give you three minutes to try this question. 4, 3, 2, 1. Pause the video and try this one on your own for about 3 minutes. Alrighty, so hopefully you did that. Hopefully you paused it for 3 minutes to try it. Let's talk about it together now. So first step is going to be plug in. If I plug in 4, I'll get 1 over 0 minus 7 over 0. So still, I have, when I think about these, because I have a non-zero over 0, I would think about these in terms of one-sided limits. And each of those one-sided limits is going to be some type of infinite thing. So an infinite thing, and then minus an infinite thing. This is indeterminate. This is indeterminate. So we need to simplify. I can't tell just seeing that it's infinity minus infinity what it's going to be. I got to simplify. So let's do a common denominator again, because we're subtracting two fractions. And again, I'll multiply the first fraction top and bottom by x plus 4 to get x plus 4 on the top, and then x minus 4 times x plus 4 on the bottom. And then minus 7 over, let's factor that second denominator, x minus 4 times x plus 4. And now when I subtract these fractions, we get the limit as x approaches 4. The top is going to be x minus 3. The bottom is x minus 4 times x plus 4. All right, so now I don't get a cancellation, unfortunately, but I've simplified it a little bit. So let's try plugging in. If I plug in 4, on the top I'll get 1. On the bottom I'll get 0 in x minus 4 times 8. And 0 times anything is 0. So I get 1 over 0. Non-zero over a 0. And our strategy there is, well, we evaluate one-sided limits. We will evaluate one-sided limits. Okay, so from here, I'm going to leave this for you to try. It would be a great practice problem to finish this off. Well, we've already done a few of these non-zero over 0 questions in the previous video. So I'm going to leave this for you. It turns out that the answer will be D and E for this, but I'll leave that for you to check. Let's do another practice problem. So this is going to be from worksheet 3, actually, the next worksheet, problem number 2, part D. I want to begin by giving you 3 minutes to try this. 4, 3, 2, 1. Pause it and try this one for 3 minutes. Okay. Hopefully you've done that. Hopefully you paused it and really tried this for 3 minutes. All right, let's talk about it together. So first, I'm going to plug in. And when I do that, I'll get square root of 1 plus 1 over. And instead of just plugging in 0 straight up, I know this is a one-sided limit. And I know at some point I may have to deal with the fact that it's a one-sided limit. So let me just start off by writing 0 plus in the denominator here rather than 0. And then I get minus square root of negative 1 plus 1 over. And same thing here. Let's write a 0 plus in that denominator. So this equals square root of 1 plus. And at this point, we've seen a few things like this, where I have a non-zero term on the top. The 0 plus on the bottom means it's really, really close to 0, but a little bit bigger than it, a little bit positive. And we've seen that when we divide by something divide 1 by something really, really small like that, the whole thing is going to be huge. 1 is positive, the denominator is positive, which means the whole thing is going to be positive infinity. And then minus square root of negative 1 plus, for the same reason, this is also going to be plus infinity. Alrighty, and if I have infinity plus 1, that's kind of like doing a huge, huge number plus 1 is still huge. That's infinity. And then doing infinity minus 1 is still going to be huge, still infinity. And then when I square root infinity, that's still really, really big, so that's going to be infinity. So I have infinity and then minus an infinity, and that's an indeterminate form. So we have an indeterminate. So we simplify. All right, so how do we simplify the square root of something minus square root of something? Well, in the previous video, we talked about that technique, multiplying by the conjugate. Let's try that. So this will be the limit as x approaches 0 from the right of square root of 1 plus 1 over x minus root of negative 1 plus 1 over x. And let's try multiplying the top and the bottom. So right now there's no denominator, so let's put this whole thing over 1. Let's multiply the top and the bottom by a square root of 1 plus x. Let's change that sign in front of that next term to a plus, and then root negative 1 plus 1 over x. Same thing on the bottom, root 1 plus 1 over x plus root negative 1 plus 1 over x. Close that parentheses. And now let's multiply out limit as x approaches 0 from the right. On the numerator, when I multiply out, I'm going to get the first term squared, which will get rid of the square root. I'll have 1 plus 1 over x. And then I get minus the next term squared. So let's be sure to put that in a parentheses, because when I do minus that whole thing, the minus needs to distribute the stuff that goes in it. Okay, so when I square that next term, it'll get rid of the square root, and I'll have -1 plus 1 over x. And that's really the power of multiplying by the conjugate. On the denominator, I have 1 times something, so that'll just be the something. Root 1 plus 1 over x plus root -1 plus 1 over x. And now this simplifies the limit as x approaches 0 from the right. On the top, after I distribute that negative, I'll be left with just 2. On the bottom, I get root 1 plus 1 over x plus root -1 plus 1 over x. Awesome. And now we will plug in. So we get that 2 on the top. I've already plugged into something very, very similar to this denominator before. I know that both of the root terms will end up being infinity. I'll get infinity. This time I have a plus infinity. So I have 2 over. Infinity plus infinity is huge number plus huge number. That's really, really huge number, still infinity. And when you divide 2 by a huge number, as an example, that's, what do I get if I get like 2 divided by a million? Divided by a million. That's going to be very small. That's like if you have $2 and you divide it amongst a million people, each person gets a super, super, super small amount. So that's approaching 0. As the denominator gets bigger and bigger and bigger and bigger, the whole fraction gets super, super close to 0. And that's my answer.